Hi everybody and welcome to section 3.2. This is systems in three variables. If you are going to understand this section, you really have to have a mastery of solving system of equations, particularly with elimination with two variables, okay? Because this is now three variables, so if you don't do two variables well, you're definitely going to struggle with three variables. So what is this talking about? Three variables. How many dimensions and why is it the number of dimensions? Well, this is three dimensions, okay? Three variables, three dimensions. When we're talking about two variables, you're talking about two dimensions, okay? With your x coordinate, your y coordinate, okay? You got up, down, left, right. With 3D, okay, three variables, you have three dimensions, and it's going to come out of your paper like this. So you have your left, right, up, down, and then you also have your in and out, and that is the variable of z. So in order to graph it, you really have to have three-dimensional space. Each equation in three variables is going to be a plane. So we have a plane drawn, okay, and then the planes can intersect. Now, the top ones are all no solution because there's not a single place where all three planes, the blue, the orange, and the yellow, intersect. We have intersections here, here, and here, but not all in one spot. The blue does not touch both the yellow and the orange at the same time in the same place. And that's definitely apparent there where they don't touch at all. Okay, and then here, same deal as the first one. The orange touches both of them, but not in the same place at the same time. One solution is when it looks like this. Notice how the blue is touching the orange, is touching the yellow, all in the same place, which is labeled with that little pink dot right there. And then you have infinite solutions where they overlap for a continuous line. That's an infinite number of solutions, and that is what that looks like. Now, all of this begs the question, is this ideal? And the answer is no. Obviously, you would have to have some sort of 3D modeling, computer programming, whatever, to see this visually. Okay, so graphing is not ideal. So the alternative is doing it algebraically. Now, once we get a solution, it's not going to be an ordered pair like we got before. It's going to be an ordered triple, because now we're talking about having three different variables, three different equations. And what are our three different variables? We have x, we have y, as before, and then we have our new friend that takes us to the third dimension, variable z. Let's go ahead and jump into solving. Woodstock's going to talk us through these problems. Okay, so what's our first step? Well, we're going to take a look at, it's best when we do this with an example, so we're going to take a look at example 1 as we go through these steps. Our first example is label the three equations. Fairly simple. It's just a way to get organized. So if we label these 1, 2, and 3, it'll be easier to know which one we've already worked with, etc. Okay, so labeling is the first part just to get organized. Step 2, choose a focus variable. Okay, this variable is going to be used to determine which one we eliminate, which I'll get to later. Now, what's ideal? Well, we have a bunch of different variables here. You can see I've already circled z, which I'll talk about in a second, but we have coefficients of 4, we have coefficients of 8, we have -3 coefficients. Ideally, we would choose a coefficient of 1 or -1, but with some slight preference to 1. 1's a little bit better because obviously it's just easier to work with than negatives. So here we see that z has a coefficient of 1, so this is going to become our focus variable. Now, the vocabulary is not that important. This is just a way for you guys to understand how to get organized and to help you guys kind of get this a little bit better, okay? The equation with the focus variable, okay, so that's number 1, equation number 1, becomes the working equation. Okay, so this is the one we're going to kind of work with, just because he's the easiest coefficient to deal with. Now, another good choice would have been this x here, but you kind of, you just can choose either one. So I chose C. And this becomes our working equation. All right, so we're done with step 2 already, it seems, and now we're ready for step 3. The reason why we label it the working equation is, of course, we're going to be pairing the working equation with what? We're going to be pairing the working equation with other equation from the system. Which one? Well, eventually both, but for our first step, or what's this, third step, we're going to pair it up with, here's our working equation right here. Oops, I didn't need to circle it. It's already circled. We're going to pair it up with the second one, okay? So to start, we're going to pair it up with the second one. And what we're going to try to do, as we see our focus variable right here. Let me highlight it in green. what we're going to try to do is we're going to try to eliminate our focus variable. That's our goal. We don't like 3 variables. We don't even like 2 variables. So first we need to get it down from 3 to 2. So we're going to eliminate the focus variable. Okay. So let's go ahead and do that. So we have z with a coefficient of 1, and we have this guy, which is -3. Lucky for us, well, it would be great if it was a -3z and a +3z. It's not. But lucky for us, 1 is a factor of -3. So what we're going to do here is we're going to multiply this by 3. Now, why are we going to do that? Whoops, sorry. We're going to do that because we want the coefficients of z's to be opposites. So we're going to multiply this 3 by every term in this equation, even the 2. Don't forget about the 2. So once we do that, we get 12x plus 24y plus 3z equals 6. Okay. Now, guess what? We have opposite coefficients with z. We have a -3 and a +3. We are ready to add these two equations together. Now, my personal recommendation is to always make them opposites. That way you're always adding. Some people like to get them to the same and subtract. My personal recommendation is always get them to be opposites and then add. Okay? Just less problems that way. Once we add, we get 13x plus 31y. And then guess what happens here? We eliminate -3z plus 3z. We eliminate the focus variable. That was our goal. And then we get equals -8. So what does this tell us? Well, this is our buddy. This is our new equation that we got. That's now only in 2 variables, which is very important because this makes it a little bit easier for us. We did a whole section on 2 variable systems. So now we have, this becomes the equation in 2 variables. This is good news for us. Now on to step 4. We're going to repeat that whole process with the remaining equation. All right. We already worked with number 2. Now we're going to work with number 3. So we have to always pair up the working equation with whatever equation we're trying to work with. We have 4x plus ay plus z equals 2. That's our working equation. Now we're pairing up with number 3. As before, we need to make sure our coefficients are the same. They're not. Luckily, z is a coefficient of 2, or 1 is a coefficient of 2 with our z variables. So we only need to multiply one of the equations. Otherwise, if one's not a factor of the other one, we'd have to multiply both. That is not the case. Now, one thing we have to keep in mind, the signs are both the same, so we're going to have to multiply it by a negative so that they become opposites. This is my personal strategy, so that's what I'm going to do. I get -8x. I get -16y. I get -2z, and I get -4. What do I do from here? Well, I should recognize, as before, now I have opposite coefficients for my focus variable. That means I am ready to rock and roll. I'm ready to add these 2 equations. I get 2x minus 8x gives me a -6x. I get -3y minus 16y gives me -19y. This eliminates. That was the whole plan since the beginning. And we get 3 plus a -4. That gives me -1. Guess what this becomes? This becomes our second equation. Okay, so I'm going to put a star by it. I always like putting the stars. It makes it a little bit more obvious that we're going to be working with these guys. And I can move this -1 over if I want, but I think it's fine. Actually, I'm going to move this guy over too. Okay, just kind of whatever. You guys get the point. I'm going to actually go against my word here. Move it over just so you can see it. So now I have my 2 equations. See my 2 stars? Those are my 2 equations. This becomes my second equation in 2 variables. Okay. Now, I have 1 equation, 2 variables, 2 equations with 2 variables. Solve the system of, oops, I already have of equations that we have. And now I'm going to put a star in parentheses just so you know which equation we're solving for. Okay. This is our star equations. That's where I like to start. These are our star equations. Solve the system of equations. Let's list our stars here. So we have our first star is, let me go ahead and rewrite it. We have 13x plus 31y equals negative 8. And what's our second star? Our second star was negative 6x minus 19y equals negative 1. Okay, this is not good. Notice how we don't have matching coefficients of x. We don't have matching coefficients of y, or opposite coefficients, I should say. And also notice how neither of the coefficients, none of them, are factors of each other. This is going to create some extra work for us. That means we have to multiply both equations to find at least common multiple. 19 and 31, I don't even want to touch that. I don't want to have to try to find at least common multiple of that. But 13 and 6 is manageable. In order to find at least common multiple of that, we can always multiply by the other number, by the other coefficient. Notice how they're already opposite signs for my x, so this is like back to systems of equations. Notice how I'm choosing to focus on the x to eliminate the x, and then I'll only have y, and I'll be able to solve for y, which is pretty cool. I'm going to go ahead and write what happens after I multiply these equations. So I multiply 13 times 6, I get 78x. Then I multiply 31 times 6, I get positive 186y. Then I get negative 48. Okay, now I have 13 times a negative 6, so I have to get negative 78x. That was the whole point in doing that. So I get negative 78x. Now I do negative 19 times 13. Oops. 19 times 13. One of them's negative. And I get negative 247, and that's y, equals, and then we get negative 13. So as you can see here, we kind of have some ugly numbers for our first example, but I promise the process is the important part. I'm just using my calculator, which you should do too for something of this kind of difficulty. And it's not so much difficult as it is just a little bit more complicated. But the process is the same. We're essentially just solving using system of equations using elimination, okay? It's not that bad, even though these numbers are pretty ugly. So what do we do? Well, the whole plan was to eliminate x, and that's what we do. We eliminated x, so that is all part of the plan. Now we have 186 minus 247, adding a negative is the same thing as subtracting. So we get negative 61y equals, and then we get negative 61. Hoo-hoo, what do you know? We're going to divide by negative 61, divide by negative 61, and we get y equals positive 1. Okay, this is a momentous occasion for us. We have our first number. Solve the system of equations. Solve for the two variables. I'm going to actually keep this in blue. In this case, it was x and y, but it could be x, y, z, or sorry, it could be x and y, it could be y and z, it could be x and z. Okay, so for this particular example, it was x, comma, y. All right, so we have our first one. What do we do once we do that? Well, we plug it back in. This is just like regular system of equations. Please check out those videos. It was 3.1 if you're interested. So I'm going to plug this back into the top equation. Okay, and what happens when I do that? I'm going to change my route here. I'm going to go like this. Okay, I'm going to plug it back in. So then I'm going to go back in orange, just so you can see it. Maybe I'll change it to purple. No, I'll keep it in blue. That's a good idea. Just trying to make this the easiest for you. Okay, so I have 13 times, I'm going to change it to orange. No, I'm going to keep it like that. Sorry. 13 times x, I don't know what x is, plus 31 times 1 equals negative 8. So now I'm just solving for x here. I have 13x plus 31 equals negative 8. I'm going to subtract 31 from both sides. I get 13x equals negative 39. Divide by 13. I get x equals negative 3. Guess what? I have my second variable. We're down to 1. We're down to our z. We already solved for our two variables, x and y. Now we're on to step 6. Plug in the values of the variables. Keep it in blue. Into any equation and solve for the remaining variable. In this case, it was z. So we're going to solve for z here. And I put that in parentheses because it's not always going to be z. It's not always going to be x and y. You're solving for those particular steps. Now, which equation should we do? Might as well use the working equation. The working equation has z by itself. So I'm going to go ahead and use number 1 here, which is, let me go ahead, and I'm just going to rewrite it so it's kind of easy for you guys to see, plus 8y plus z equals 2. Now I'm going to rewrite this all with my new and improved values, plus 8 times something plus z. This is the guy I'm trying to find, equals 2. Now what are my new values? Well, I have negative 3 for x, I have positive 1 for y, and now let's move on to the best part. Just because it's emphasis, I'll just change to purple. Very important. Plus 8 plus z equals 2. This equals negative 4 plus z equals 2. I'm going to add 4 to both sides, and I get z equals 6. So I'm done. Okay, I found my last one. And now what you should do is you should write it as an ordered pair. So what is my solution? My solution is my x first, negative 3. My y, 1. And my x, 6. And I am done. There is my solution. So if we were to graph this into 3D coordinate plane, this is where the intersection of these 3 equations would be. That was a pretty long one. We're going to do some examples in the next video, so stay tuned. Thank you so much for watching.